Hi, Cullen. These are the problems that you sent to me tonight. This is the section number that was at the top of the page in the photo of the book that I saw. So hopefully you can match the questions as I'm showing them here to what you have in your homework for this week. The good news, Cullen, is that this is super straightforward. I'm sure these things are all going to look familiar to you once we dig in a little bit, and you probably know a lot more of this than you think you know. What I'd like you to do is grab some paper and pencil right now, maybe just whatever you're doing, however you do your homework, we can just get it done right now. And what I'm going to do is I'm going to introduce each question by giving you the formula, giving you a little background, so that you know how to approach it. Then what I'm going to ask you to do is pause the video, work the problem yourself with the numbers that are there, and then play again, and I will go through the answer and make sure that you got it right. But I want you to have the opportunity of trying each problem on your own. I see that you have the correct answers. They were circled in your book. So you, which is really good, because I think that doing math problems without the answers is a ridiculous waste of time. So let's dive in. All of these questions in this section that you sent me have to do with area. And whenever you think of area, I want you to imagine a two-dimensional object. It can be fabric. It can be paper. Those are two of my favorite ones because that's something that we lay out and measure quite typically. Fabric is the best one. Any kind of fabric, whatever you might use it for work, but making a tablecloth, that kind of situation. Area contrasts, area is two-dimensional, with line. That's a one-dimensional object. That's when we're just measuring the length of something, of string, of the perimeter of your yard for the new fence that you're going to have built, that kind of thing. So that's one-dimensional. And then the 3D is volume. That's when we're measuring like how much water it would take to fill up a certain sized cube. So I'm highlighting this because I want you to remember what it is that we measure when we're measuring area. 2 dimensions. And we usually call the longer dimension length, and the shorter dimension we call the width. Although honestly, it doesn't really matter that much. So when we've got it doesn't matter which you call length and which you call width. I'll illustrate in this problem. So when we want to find the area of a rectangle, excuse me. This is how I abbreviate it for my notes. The area of a rectangle equals length times width. That's a cursive L rather than just a regular L, because then that would look like a 1. Length times width, these words here. This is what I recommend that you write on the inside of your notebook or on a special piece of paper. You're going to want to collect up all of your formulas and keep them in one place. So the area of a rectangle is to multiply the length times the width. Now here it says it's 8 feet long and 4 feet wide, so it's very clear which number is which. But as long as we know that we're taking one side of the rectangle and multiplying it by the other, we're good. Don't get tripped up in those words. So right now, let's remember this is multiplying. The dot means multiplying. So all you need to do is multiply 8 times 42, and that will get your answer. So pause me and do it. All right, I'm assuming you're back now. I'm going to take this formula and I'm going to plug in 8 is the length times 4 is the width, and that gives me 32. And then we always put a unit on these kinds of problems. I tend to write it like this, squared inches. I noticed that in your answers, it's typically presented like so. Oh, it's feet rather, sorry. It's feet, not inches. My mistake. it's feet. But your answers tend to prefer this notation where they write square-foot, which just stands for square feet, and this does too. Mathematicians tend to prefer this, but you know, I guess electricians like it the other way. So there's your answer. Beautiful. Let's go on to the next one. The area of a 16 centimeter square is, okay, well now, wait a minute, this is confusing. Squares and rectangles, are they alike or are they different? Ah, they're kind of both. Let's look at the formula for the area of a square. Now a square has the same side, the same length on all four sides, right? So instead of calling them length and width, we just call them side and side. Let me just put this into this picture. I'll write it on the inside kind of so it doesn't go there, right? That's where we get that information. That helps you match the side to the name. In a square, they aren't different. They're all the same. So S equals side. So we just say, we're multiplying the side by the side. So what we can say is it's equal to the side squared, or the side times the side is another way to say it. If that exponent makes you feel woozy, we just multiply the side by the side, and that's how we get the area of a square. We only need one dimension because they're all four the same. Okay, pause me, try that now. Multiply the side times the side, and then I'll be ready to show you when you're done. Okay, so what I'm going to do is I'm going to multiply 16 times 16. And remember, the dot means multiplication. I didn't say that before. And let's say that I don't know the answer to that. So I'm going to multiply it. I'm going to assume that you might be a little rusty on multiplication. I also am going to assume that you're not using a calculator. I highly recommend that you do your calculations by hand rather than a calculator because it sharpens your brain and it's like working out. If you want to be physically fit, then you're not going to lie on the couch and watch yoga videos. You're going to get up and do something. And math is the same way. You sit there pushing buttons on a calculator. It makes your brain lazy. Don't do it. Okay, so the way we multiply, I'm going to scoot up a little. We start in this corner, right, with this digit, and we multiply up. 6 times 6 is 36. Put down the 6, carry the 3. Now we go 6 times 1. Oh, that's 6. And then we add the part that we carried. So 6 times 1 is 6, plus 3 more is 9. Now we're going to multiply this digit, which is not multiplying by 1. It's actually multiplying by 10, isn't it? So we put a 0 down here to reflect this extra place and to recognize that we're actually multiplying by 10 and not just by 1. But now we can ignore the fact that we're multiplying by 10 and just do the multiplying by 1. 1 times 6 is 6. 1 times 1 is 1. We've got everything multiplied, and now our last step is to add. 6, 5, 2. So our answer is 256 square centimeters is the right answer for this one. I don't remember which, excuse me, I don't remember which letter they are, but these are all the answers that were circled in your paper. All right, problem number 3. And again, let me say this. If you didn't do it already, you'll want to write this formula down on that special piece of paper where you're keeping all your notes. I call these puffy clouds of knowledge. And whenever I make one of those on a paper, then you can be pretty darn sure that what I've put inside of there is important. All right, problem 3 is the toughest one of the bunch. The area of a circle with a 14-foot diameter. All right, this word throws a lot of people off. What does that even mean? So let's look. Here's a circle. Every circle has a center, and a diameter is a line that starts on one side of the circle, goes through the center, and then continues on straight out the other side of the circle. And you can draw lots and lots of them, an infinite number. I'll draw one like that. That whole thing is called the diameter. Okay? But sometimes we say, well, we don't want to look at the whole length of the circle. We just want to go from the center to the edge. And again, there's an infinite number of those that we can draw. That is called the radius. And a cool thing is that if you take two radii and add them or multiply them, it's the same difference, you'll get the diameter. Okay, so the radius is half the diameter is twice the radius. I just said the same thing twice in two different ways. All right, so if we want to find the area of the whole circle, this formula is a little trickier. Area of a circle equals, ready, pi r squared. Okay, pi is a special number that the Greeks found, and they named it after one of the letters in their alphabet. That's why we call it pi, and that's why we make this symbol. And what they noticed is that in every single circle, no matter how big or how small, there's a relationship between the length of that radius and the area of the circle. So without going into a lot of drama about how they figured that out and how exactly it works, let me just tell you that pi is always equal to 3.14. Now, it's not exactly equal to 3.14. That's why I put that little wanchajiggy there. And technically, I should have two of them and no equal sign, which means approximately equal to. This number has a ton, an infinite number of decimal places. But for intermediate level calculations, which is what you're doing, we usually round to 2 decimal places. So we'll keep it at 3.14. So what we have to do is we have to multiply 3.14, and I'm going to show the multiplication this time. This implies multiplication. When we bump two symbols up against each other like that, we're multiplying. We can also use parentheses to show multiplication. Now I need to know what the radius is of this circle that we're talking about. Well, this says it has a 14-foot diameter. So it's all the way across is 14 feet. But I don't want the diameter, I want the radius. So how am I going to find the radius? I take half of the diameter. But then I have to square it. The formula tells me I have to square that. And remember that when we have exponents, what that means is we're multiplying this number, which is called the base, times itself this many times. So we can rewrite this, if we want, as 3.14 times 7 times 7, or we can write it as 3.14 times 49, because 7 times 7 is 49. There, I helped you get started. Now pause me and see if you can multiply those two together and get a lovely answer. All right, I assume you gave it a shot. Let me try it with you. 3.14 times 49. I put the number with more digits on top. You can do it either way, but that just looks neater and more organized to me. I make the decimal really strong, and then I ignore it until the end of the problem. That's how we handle decimals in multiplication. Now I'm going to multiply just like before. I start here. 9 times 4 is 36. 9 times 1 is 9, plus 3 more is 12. 9 times 3 is 27, plus 1 more is 28. You're so lucky that you're not here, because I'd be making you do all the heavy lifting of multiplying. All right, now I'm going to multiply by 4, but I want to recognize that it's actually 40, right? It's 49, so that 4 represents 40. So I put a 0 here, then I start multiplying. 4 times 4 is 16. I put down the 6. Now I'm going to cross out that 3 so it doesn't confuse me and put a 1 there. 4 times 1 is 4, plus 1 more is 5. And then 4 times 3 is 12. Now I add 6, 8, 3, 5, 1. And now for my last step, I go back and I count how many digits were behind the decimal in the original two numbers. We call them factors. That's fancy. But look, there were 2 digits behind this decimal point, and then this one, well, the decimal was there, right? So there weren't any digits behind it. So if I have 2 digits behind decimals in my problem, then I have to put 2 digits behind decimal in my answer, counting from this side that way. So my final answer is 153.86 square feet. That's my final answer. And there is that beautiful formula with the value of pi, because you have to know that in order to make this thing work, right? That's the hardest one. Make sure you get that copied into your book. Go ahead and pause me now if you need to do that. All right, we're back for number 4. So we did a rectangle, a square, a circle, and now we're ready to do a triangle. The area of a triangle with a base of 4 centimeters and a height of 6 centimeters is blankety. All right, now triangles can be a little bit tricky. So let me show you how these words, base and height, relate to the picture of a triangle. The base just means whatever's sitting on the ground, if you will. The base is usually the easy part to find. The height is the tricky part, because depending on how the triangle is shaped, right, it could be shaped like this, or it could be shaped like that, or it could even be shaped like this, right? Triangles can get crazy. So how do we find the height of a triangle? It is not necessarily one of the sides. What we do is we send a spider in to help us out with this. We send a spider in to climb to the highest point of the triangle. There's my spider. My spiders only have 6 legs because otherwise they look really messy. And what we ask our spider to do is to drop a line straight down to the base at a perfect right angle. Wherever that line is, that is the height. Okay, so sometimes it goes down the middle of the triangle. Here's my spider up here. This time, the web goes right down that outside edge. But here, let me redraw that one so I can draw my spider better. Sometimes when the spider drops her line, it's outside the actual triangle. All right, so there it is down there. So the height of the triangle is something different in most cases than one of the sides. And as long as they tell you very directly, then you're fine. But sometimes that's a little trick that gets thrown into problems, is that they'll tell you the side of the length of the side and the height. So I want you to be aware that those are 2 different things. Okay, so now we need a formula. The area of a triangle equals base times height divided by 2. Okay, we always divide by 2. So go ahead, use this formula, write it in your book or on your page or whatever it is you're doing. And then if our base is 4 and our height is 6, go ahead and calculate the answer for this problem and then play me again. All right, it's my turn to work it. It says the base is 4. And, whoops, I made it look more like a decimal. And the height is 6. We divide by 2. Okay, and then the way I calculate this is I multiply straight across here, and I get 24 over 2. And then remember, we can reduce fractions if we divide the top and the bottom by the same number. And I'll get into the theory of that later, but for now, just remember, as long as you're dividing top and bottom by the same number, you're good. I'm going to divide both of these by 2. I can see they're both even numbers, so I know I can divide by 2. And this will become 12 over 1, or 12 centimeters squared. Is that the right answer? Yes. Okay. So there we go. Rectangle, square, circle, triangle. And then our last problem takes us back to the beginning. And it says find the area of a rectangle that is 14 meters long by 5 meters wide. So what I like to do with a problem like this is just sketch it out. It doesn't have to be perfect or proportional, but there's my rectangle. It's 14 meters long, so I'm gonna put 14 there, and then 5 meters wide, so that's there. That helps me remember that my formula is, sometimes I like to just write it right in the middle, length times width, right? And so I go 14 times 5. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. So my answer is 70 square meters. And that's the right answer. Oh, I forgot to tell you to pause and do it by yourself. Oh well, I helped you on that one. All right, Cullen, those are the 5 problems you showed me. When you get a chance to look at this, message me back, tell me how it went, and then send me your next page full of problems, and we'll tackle them. Thanks, bye.